What is a chromatography?
A process to separate mixtures, generally by differing affinities of to a solid stationary phase.
What is a chromatography?
A process to separate mixtures, generally by differing affinities of to a solid stationary phase.
What are colligative properties?
Properties of a solution that depend on the amount of solute dissolved.
What are colligative properties?
Properties of a solution that depend on the amount of solute dissolved.
What is the collision frequency?
Average number of collision events per second.
What is the collision frequency?
Average number of collision events per second.
What is the collision theory?
Defines reaction rates as a function of the collision frequency.
What is the collision theory?
Defines reaction rates as a function of the collision frequency.
What is a colloid?
Suspension of particles of one substance in another, e.g., milk.
What is a colloid?
Suspension of particles of one substance in another, e.g., milk.
What is combustion?
A chemical reaction between a fuel and an oxidant to produce heat.
What is combustion?
A chemical reaction between a fuel and an oxidant to produce heat.
What is a compound?
A substance composed of more than one element.
What is a compound?
A substance composed of more than one element.
What is condensation?
Conversion of a gas into a liquid.
What is condensation?
Conversion of a gas into a liquid.
What is the boiling point?
Temperature for a given liquid at which its vapor pressure is equal to the external pressure acting on it.
What are colligative properties?
Properties of a solution that depend on the amount of solute dissolved.
What is a bond strength?
A measure of the energy required to break a chemical bond.
What is a calorie?
A unit of energy equal to 4.184 joules.
How can I grow crystals of rock candy?
Chemistry principles encountered in this experiment, crystallization and recrystallization solubility materials you'll need. Sugar, 3 cups, water glass jar a pencil string, cotton. 15 centimeters will do, pan, for boiling water, microwave or stovetop, optional, food coloring, optional. Flavoring extracts. The procedure, begin by stirring 3 cups of sugar and 1 cup of water into a pan. While stirring frequently, heat the mixture to a gentle boil. The goal is to just barely get the mixture to its boiling point. And then stop the heating, we don't want to evaporate off too much of the water. Then remove the solution from the heat source. If you want to add food coloring or flavoring, now is a good time to do so. Either way, the candy is made of sugar, so it will still taste fine. Cool the pot containing the solution in the refrigerator until it's just below room temperature. In the meantime, tie the cotton string to the pencil, and place the pencil atop the jar. allowing the string to dangle down without touching the bottom. You may need to trim the string such that it doesn't touch the bottom of the jar. You may wish to tie a lifesaver candy or other weight to the end of your string to hold it taut. Wet the string and dip it in a little bit of crystalline sugar. Not the sugar you just mixed with water and heated. These sugar crystals will serve as the nucleating sites on which the rock candy from your sugar solution will crystallize. Pour the cool sugar solution into the jar, and hang the pencil and string into the solution. Cover the jar with aluminum foil, a paper towel, or anything else, such that it will not be disturbed. The crystals will take several days, or possibly as long as a week, to grow. Sugar from the solution will continue to crystallize onto the growing crystals on the string. You can check on the crystals occasionally, but you should not bump, tilt, turn, shake, or move the jar, if possible. The crystals will grow larger if you leave them undisturbed. Once they are done growing, remove your string, and your rock candy is ready to eat.
What is a bonding orbital?
A molecular orbital that is more stable than the atomic orbitals that were combined to generate it.
How can I grow a large crystal?
Chemistry principles encountered in this experiment, crystallization solubility materials you'll need. Hot water, from the tap is fine, about 2.5 tablespoons of alum. This is typically found with the spices in the grocery store. It is an ingredient used to make pickles crisp. Its chemical formula is Kal, so 212H2O, nylon fishing line or thread, about 15 centimeters. A pencil or ruler, 2 jars, spoon, coffee filter or paper towels. The procedure: pour 1/2 cup of hot water into a jar. Add a little bit of alum to the water and stir it in. Try to do this before the water cools down too much. As you'll recall, we can expect the alum to be more soluble at higher temperatures. We want to create a saturated solution of alum, but we also want to make sure that all of it dissolves. Continue adding alum until it will not dissolve anymore. And then you can add a little bit more hot water to get the last bit of alum to dissolve. Cover the jar with a coffee filter or paper towel and let it sit overnight. The next day, pour the liquid into a second jar. There should be small crystals left in the bottom of the first jar. The process of pouring the liquid off of the top of the solid crystals is known as decanting. The crystals left behind will serve as the seed crystals to grow a larger crystal of alum. Pick out the largest crystal, or one with a nice shape that you like. Tie the fishing line or thread around the crystal. And tie the other end of the line to a pencil, ruler, or other long flat object. Adjust the length of the string such that you can use the pencil or ruler to dangle your crystal from the top of the second jar. the one that now contains the liquid, into the liquid without it touching the bottom. Once your crystal is hanging into the solution, all you have to do is sit back and wait for it to grow. This might take several days. If you notice small crystals growing on the sides or bottom of the jar, it would be a good idea to transfer the solution and your single growing crystal into another jar to prevent the alum in solution from crystallizing into several different crystals. This will ensure that you get a nice big crystal. You can feel free to transfer jars as many times as necessary to continue growing your large crystal. History of Chemistry Timeline Year Event 1859 to 1860 The early foundations of spectroscopy are established by Gustav Kirchhoff and Robert Bunsen. 1864 The Law of Octaves. An important step leading to development of the modern periodic table, is first proposed. 1865 The number of molecules in 1 mole of a substance is first determined. 1869 Mendeleev publishes the first version of the modern periodic table, containing 66 elements, and leaving space for yet to be discovered elements. 1869 DNA is first discovered. 1874 The second law of thermodynamics is proposed by Lord Kelvin. 1874 Electric current is proposed to be caused by the motion of electrons. 1876 The concept of free energy is introduced, by Josiah Willard Gibbs to explain chemical equilibria. 1877 Ludwig Boltzmann provides a definition of entropy, along with statistical derivations of several other physical concepts. 1884 Le Chatelier's principle is first introduced, explaining changes in chemical equilibria upon the introduction of changes in a chemical system. 1887 The photoelectric effect is first discovered. 1888 Radio waves are discovered by Heinrich Hertz. 1893 Alfred Werner establishes that some cobalt complexes involve a central cobalt atom bonded to an octahedral arrangement of 6 ligands, laying the groundwork for the field of coordination chemistry. 1894 Noble gases are first discovered. 1895 X-ray radiation is discovered. 1897 The electron is discovered. 1900 Planck's constant is first introduced by Max Planck. 1900 Ernest Rutherford establishes that radioactivity is caused by the decay of atoms. 1901 The Nobel Prizes are awarded for the first time.
How can I extract iron from oatmeal or breakfast cereal?
Chemistry principles encountered in this experiment: magnetism, food chemistry / nutrients extraction materials you'll need. Oatmeal experiment iron fortified instant oatmeal packet, check the label to ensure iron content. Magnet, it's easiest to see the iron if you can find a magnet that is coated or painted white or another light color. Plastic bag or bowl BRE fast CEREL XPERIMENT magnet for this experiment. You will want a magnet you can use to stir a liquid. It's easiest to see the iron if you can find a magnet that is coated or painted white or another light color. Plastic bag, water, large glass jar or beaker. The procedure: oatmeal experiment. Open the oatmeal packet and empty it into the plastic bag or bowl. Stir the oatmeal with the magnet. You should see small amounts of gray or brown metal collect on the outside of the magnet. This is iron. Iron is commonly added as a mineral supplement to breakfast cereals and other foods. Now you can see that the iron that goes into your diet is the same element that you find in objects made of iron metal, just in much smaller quantities and pieces. Recall that iron is attracted to magnets due to the fact that it is a ferromagnetic material. See atoms and molecules. BRE fast CEREL XPERIMENT. Pour 1 or 2 cups of breakfast cereal into a plastic bag. Crush the cereal inside the bag using your hands. Pour about 1 liter of water into the jar or beaker, and add the crushed cereal from the bag to the water. The water will help to extract the iron from the crushed cereal. Whereas the iron bits were looser in the dry oatmeal sample, they tend to be stuck within pieces of cereal. Which is why you need to mechanically crush the cereal and use the water to help extract it. The magnetic interaction wouldn't be strong enough to pull the iron out of the cereal on its own. In a chemistry lab, acids would often be used to help extract metals from a sample. But will work fine for our purposes here. Use the magnet to stir the crushed cereal for about 15 minutes. When you remove the magnet from the water, you should see iron filings collected on the magnet.
What is a bond length?
The distance separating two chemically bonded atoms.
What is black body radiation?
Electromagnetic radiation given off by a black body. At room temperature, most of this radiation is in the infrared. But at higher temperatures, visible light can be emitted.
How can I make a lava lamp at home?
Note: okay, so we'll disclose up front that this experiment won't actually make a lamp. It will make a device with bubbles that rise and fall just like a lava lamp. But you'll need a flashlight or other light source if you want it to be illuminated. Chemistry principles encountered in this experiment: chemical reactions, density, miscibility, gases, materials you'll need. Vegetable oil, 20 ounces. Plastic soda bottle, 20 ounces or 1 liter, water, 1 tablespoon. Alka-Seltzer, R, Food coloring. The procedure: begin by filling the plastic bottle almost full with vegetable oil. Add a few drops of food coloring to 1 tablespoon of water. And then add this to the plastic bottle's contents. You'll notice that the oil and water are not miscible, which is what will allow us to make bubbles within the oil. The water sinks to the bottom of the bottle, since it is more dense than the oil. Ground up an Alka-Seltzer, R, tablet and add the pieces/powder to the bottle, and then seal the cap. When the chemicals in the table dissolve and react, carbon dioxide gas bubbles will be formed, see equation below, which will lower the overall density of the water bubbles, allowing them to rise to the top of the bottle. When they reach the top, they will leave the water bubbles and join the small amount of air at the top of the bottle. At this point, the water bubbles will again be denser than the oil, so they will sink back to the bottom of the bottle. This process will repeat until all of the Alka-Seltzer, R, has been reacted. You should see colored bubbles move throughout the bottle, similar to a lava lamp.
How can I make a cloud form in a bottle?
Note: this experiment involves fire and flammable materials. Adult supervision is a must. Chemistry principles encountered in this experiment: ideal gas law, phase changes, droplet formation, materials you'll need: 20-ounce or 1-liter plastic soda bottle, warm water, 1 to 2 ounces. Matches the procedure. Add warm water to the soda bottle until the bottom is just barely covered with water, with the bottle tipped so that you don't burn yourself. Ignite a match and insert the burning end of the match into the bottle. Allow the bottle to fill up with smoke. When the bottle is fairly filled with smoke, or when the match goes out, remove the match and screw the cap on to close the bottle. Clouds will form when water vapor forms small but visible droplets around particles in the air. In this experiment, the smoke will provide these particles around which the water can form small droplets. With the bottle closed, squeeze it several times. You should see a cloud form when you squeeze the bottle. The temperature of the gas inside may temporarily increase, but the temperature will quickly equilibrate with the surroundings. Recall the ideal gas law we discussed in Atoms and Molecules, PV equals NKBT. When you release the squeezed bottle, the temperature inside decreases, cooling the water vapor and helping it to liquefy into droplets on the particles provided by the smoke. This is very similar to how real clouds are formed in the atmosphere.
What is a chemiluminescence?
Emission of light resulting from a chemical reaction.
What is condensation?
Conversion of a gas into a liquid.
What is combustion?
A chemical reaction between a fuel and an oxidant to produce heat.
What is the collision frequency?
Average number of collision events per second.
How can I make a miniature rocket from a film canister?
Chemistry principles encountered in this experiment, gases and pressure chemical reactions materials you'll need. An empty, plastic 35 mm film canister, which are getting more and more rare these days. If you cannot locate one of these, you could try using any other small, lightweight, plastic container with a lid that easily pops on or off. An Alka-Seltzer, R, or other antacid tablet water the procedure. This experiment should be performed outdoors in an open area. Add about 1 teaspoon of water to the film canister, and leave the lid open. Break the antacid tablet in half and get ready to add it to the container. This step requires you to be quick. Drop the broken antacid tablet into the container. Then quickly close the lid and place the canister on the ground with the cap side down. Stand back a good distance, and wait for the rocket to launch. The Alka-Seltzer, R, will react with the water in a reaction that produces carbon dioxide gas. The pressure of this gas will build and build until it exerts a force so great that it will blast the canister off of the cap, shooting the canister into the air. After about 10 to 15 seconds, the canister will launch into the air. Try repeating this experiment using different ratios of Alka-Seltzer, R, to water, or using canisters of different types or sizes. You might also compare different brands of antacid tablets, or different methods for crushing the tablet before you add it to the canister. Compete with your friends to see who can make the rocket that shoots the highest.
What is the boiling point elevation?
A colligative property, the increase in boiling point of a liquid as a solute is added.
What is a bond angle?
The angle relating the orientation of two bonds connecting three atoms.
What is a calorimeter?
A tool used to measure the heat change associated with a chemical reaction.
How can I make a pH indicator at home?
Chemistry principles encountered in this experiment: extract ions, acid/base chemistry, chemical indicators, solubility and temperature. Materials you'll need: several leaves of red cabbage, blender 1. Coffee filter, large jar, glasses or clear cups, water, stovetop or microwave pot or pan. You only need some, not necessarily all, of the following ingredients: baking soda, 1 to 2 teaspoon, lemon juice, 1 to 2 teaspoon, vinegar, 1 to 2 teaspoon, ammonia, 1 ounce of household variety like what you use for cleaning, antacids. 1 tablet, Alka-Seltzer, R, works. The procedure: cut about 2 cups of cabbage and place it in a blender. Boil water in a pot, and then add boiling water to the cabbage in the blender. Turn on the blender and blend for about 10 minutes. The hot water will extract a pigment called an anthocyanin from the red cabbage, along with other components. Recall that solubility tends to increase at higher temperatures. Anthocyanins are molecules that will change color depending on the pH of the solution. This will serve as our indicator. Filter the plant material out by pouring the solution through a coffee filter and into a large jar. The liquid you obtain should be red/blue/purple in appearance. The exact color you observe will depend on the pH of the water you are looking at, which may be influenced by factors like the ion concentration in your tap water and the other plant components that remain in the solution. Pour the solution into various glasses or clear cups. These will be your individual test beakers where you can test the pH of various substances. Try adding other substances to your solutions and observe how the color changes as they are added. Note that the amount of solution you add to each glass/cup will influence the amount of each test substance, e.g. lemon juice, you need to add to see a color change. For reference, the list below tells you how the color of your anthocyanin indicator solution should change with pH. Approximate pH: color 2 red, 4 purple, 6 violet, 8 blue, 10 blue, green, 12 yellow, green.
How can I make a chicken bone flexible?
Chemistry principles encountered in this experiment: solubility in weak acids. Materials you'll need: a jar vinegar, enough to fill the jar, a chicken bone. One from a drumstick works best. The procedure: obtain a chicken bone, and clean it well. Rinse it with water and remove any remaining skin or meat from the bone. Before you soften the bone, try bending it to make sure it is rigid. Don't break it, but test that it is indeed hard. Fill up the jar with vinegar and drop your clean bone inside. Cover the jar, just so that your whole house doesn't start smelling like vinegar, and let it sit for about 3 days. Recall that vinegar is a dilute aqueous solution of acetic acid, which is a weak acid. Over a few days, the acetic acid helps to dissolve the calcium in the chicken bone. Since the calcium plays a key role in keeping bones hard, the bone will soften once the calcium is dissolved. Remove the bone, rinse it off with water, and now try bending it again. It should be noticeably more flexible than before. Now you can see that without enough calcium, your bones will not stay strong. This might also provide a good indication of why it's a good idea to brush your teeth. If you leave behind any foods capable of dissolving calcium still on your teeth, your teeth may lose some of their calcium and begin to become weak.
How can I suck an egg into a bottle?
Chemistry principles encountered in this experiment: combustion pressure, ideal gas laws, materials you'll need. Hard-boiled egg bottle or flask with an opening slightly smaller than the egg's diameter, paper. A sheet of computer paper or newspaper will do, matches the procedure. Note, this experiment involves fire and flammable materials, so adult supervision is a must. Peel the hard-boiled egg. Tear off a piece of paper that can easily fit into the bottle, and carefully light it on fire and drop it into the bottle. Quickly place the egg on top of the bottle, covering the opening. The flame will burn, heating the air inside the bottle. This causes the air to expand, and some of it will push past the egg to escape from the bottle. Recall from our discussion of the ideal gas law that, for a fixed number of particles and volume, the pressure inside the bottle should increase linearly with increases in temperature. The increased pressure is what pushes the air out. And you may even see the egg shake a little as the air escapes. Then the egg will come to rest, covering the opening. Eventually, the fire will burn up all of the paper, or all of the oxygen inside the bottle. Whichever comes first, and then the air in the bottle will begin to cool. As it cools, the volume it occupies will decrease, lowering the pressure inside the bottle relative to that outside the bottle. The higher pressure outside the bottle is what pushes the egg through the opening and into the bottle. You can get the egg back out by tilting the bottle upside down and blowing air into the bottle, and then allowing the egg to cover the opening before removing your mouth. Thus you can use the same principle regarding equilibration between high and low pressures to force the egg out.
How can I make glue from milk?
Chemistry principles encountered in this experiment: solubility, precipitation, filtration, materials you'll need. Hot water, from the tap, is fine, room temperature water 1 tablespoon. Of vinegar 1/2 teaspoon, baking soda, coffee filter cup, spoon, small bowl, tablespoons, powdered milk. The procedure: dissolve 2 tablespoons of powdered milk in 1/4 cup of hot tap water. Mix in 1 tablespoon of vinegar and stir the solution well. Recall that household vinegar is a dilute aqueous solution of acetic acid. At this point the milk should begin to form little blobs of insoluble material, curd. These are a substance called casein, which are a class of proteins found in milk. Proteins are typically soluble in water and aqueous environments. But the acetic acid from the vinegar causes the casein to no longer be soluble in this solution. Position a coffee filter on top of a cup and pour the solution through the filter to collect the curd. To further dry the curd, try to use the filter to squeeze out any remaining liquid. Dispose of the liquid in the cup, dry the inside of the cup. And then transfer the curd from the filter into the now dry cup. Break the curd into smaller chunks using a spoon. This will help it to mix more readily with the ingredients you will add next. Add 1 teaspoon of hot water, and 1/4 of a teaspoon of baking soda to the cup, containing the chopped up curd. The mixture may foam a little from the reaction of the baking soda with the remaining vinegar, producing carbon dioxide gas. Stir this mixture, which should eventually become smooth and liquid-like. You may need to add a little more water or baking soda to reach a smooth, even consistency. Now you have your glue. You can use it just like you would any other glue, though you should test it out first, to make sure it's working well before you use it for that science fair project you're finishing up.
What is a chromatography?
A process to separate mixtures, generally by differing affinities of to a solid stationary phase.
How can I inflate a balloon using yeast?
Chemistry principles encountered in this experiment: biochemical/enzymatic reactions, gases, materials you'll need. Yeast, 5 to 10 grams powder yeast, a small plastic bottle, preferably about 16 ounces. Or smaller, 1 teaspoon of sugar, a balloon, warm water. The procedure: add enough water to a small plastic bottle to fill it up about 1 inch. The water needs to be warm for the yeast to do its job. Add about 5 to 10 grams of yeast, 1 small packet will do, to the bottle, and mix it around well. Yeast is made of fungal microorganisms that will become active when placed in the warm water. Add a teaspoon of sugar to the water. The sugar serves as the food for the yeast microorganisms. They are going to consume it and produce carbon dioxide gas as a byproduct. Wrap the balloon around the open end of the bottle. You may wish to use tape or a tight rubber band to prevent gas from escaping. Let the yeast do their job for about 20 minutes. And the yeast should soon produce enough carbon dioxide gas to start filling up the balloon. This is the same thing that happens when you use yeast to bake bread. The little holes you see in the bread are from the yeast releasing carbon dioxide as it rises. Try repeating the experiment using different amounts of water. sugar, and yeast, and observe the rate at which the balloon inflates. One hypothesis you might test is whether the concentration of sugar in the water affects the rate of carbon dioxide product. You might also try varying the amount of yeast you use. Pay attention to both the rate at which the balloon inflates, and the final volume of gas it reaches.
What is a compound?
A substance composed of more than one element.
What is a bond order?
Number of pairs of electrons shared by two atoms.
What is a colloid?
Suspension of particles of one substance in another, e.g., milk.
How can I make jello, R, that glows under a black light?
Chemistry principles encountered in this experiment: fluorescence gels, cross-linking materials you'll need. Jello, R, or gelatin powder, 1 cup of tonic water, 1 cup of water, stovetop or microwave large bowl pot. For heating on stovetop, a black light source. See Physical and Theoretical Chemistry to review how black lights work. The procedure: heat 1 cup of water to a boil. Mix the Jello, R, and the hot water into the bowl, and stir the powder in until it dissolves. The hot water helps the gelatin to dissolve and disperse evenly throughout the solution. Gelatin is a form of collagen, see Chemistry in the Kitchen, and when it cools, the Jello, R, will reform cross-links between the collagen strands, which is what traps the water inside to create a gel. You'll recall that a gel is solid material that consists of a bonded network of long strand molecules that contain significant amounts of molecules that would otherwise behave as a liquid trapped within the solid network. Add in 1 cup of tonic water, stir the solution well, and then place it in the refrigerator for about 4 hours. The tonic water contains a molecule called quinine that will fluoresce a bright blue color when excited with the appropriate wavelengths of light, which can be provided by the black light. Recall that fluorescence takes place when a molecule absorbs light at one wavelength, relaxes to release a fraction of that energy, and then emits a photon at a longer wavelength, lower energy, than that which was absorbed. Black lights provide light that is at slightly shorter wavelengths, higher energies, than light in the visible spectrum. So it can often excite molecules that will fluoresce in the visible region of the spectrum. When the Jello, R, is finished hardening, take a look at it under the black light. It should glow blue. This is due to the fluorescence of the quinine from the tonic water. This blue glowing color comes from the fluorescence of the quinine molecules. So it will not be affected significantly by the flavor or color of Jell-O, R, that you decided to use.
What is a chirality?
A geometric property of a molecule whose mirror image is non-superimposable with the original molecule.
What is a chiral center?
An atom whose arrangement of substituents is non-superimposable with its mirror image.
What is a chemical change?
A process that alters the arrangement of atoms in a substance.
What is the collision theory?
Defines reaction rates as a function of the collision frequency.
What is the Boyle's law?
Law stating that the pressure and volume of gas are inversely proportional.
What is a buffer?
A solution that tends to resist changes in pH upon addition of an acid or base.
What is the condensation reaction?
A reaction in which two molecules combine to form one larger molecule, with the concurrent loss of another small molecule like water or HCl.
What is the condensation reaction?
A reaction in which two molecules combine to form one larger molecule, with the concurrent loss of another small molecule like water or HCl.
What is a congener?
A polymer of two or more monomers.
What is a congener?
A polymer of two or more monomers.
What is a coulomb?
The standard unit of charge, defined as the amount of charge delivered by 1 amp in 1 second.
What is a coulomb?
The standard unit of charge, defined as the amount of charge delivered by 1 amp in 1 second.
What is the Coulomb's law?
Law describing the force between a pair of charged particles separated by a distance.
What is the Coulomb's law?
Law describing the force between a pair of charged particles separated by a distance.
What is a covalent bond?
The equal, or near equal, sharing of electrons between two or more atoms.
What is a covalent bond?
The equal, or near equal, sharing of electrons between two or more atoms.
What is the critical point?
A set of conditions at which no boundary exists between two phases of a substance.
What is the critical point?
A set of conditions at which no boundary exists between two phases of a substance.
What is a crystal?
A solid with an ordered arrangement of atoms of molecules.
What is a crystal?
A solid with an ordered arrangement of atoms of molecules.
What is the crystal field theory?
A model used to describe the electronic structure of transition metal molecules, particularly the energy of the d orbitals.
What is the crystal field theory?
A model used to describe the electronic structure of transition metal molecules, particularly the energy of the d orbitals.
What is crystallization?
Formation of crystals from a solution of the compound, often used as a purification technique.
What is crystallization?
Formation of crystals from a solution of the compound, often used as a purification technique.
What is the Curie point?
The temperature at or beyond which a ferromagnetic material becomes paramagnetic.
What is the Curie point?
The temperature at or beyond which a ferromagnetic material becomes paramagnetic.
What is a d orbital?
An atomic orbital with an angular momentum quantum number of 2.
What is a d orbital?
An atomic orbital with an angular momentum quantum number of 2.
What is Dalton's law?
A law regarding partial pressures of gases that states the total pressure of a mixture of gases is equal to the sum of the partial pressures of each individual component.
What is Dalton's law?
A law regarding partial pressures of gases that states the total pressure of a mixture of gases is equal to the sum of the partial pressures of each individual component.
What is adsorption?
Capture of one material onto the surface of another.
What is an alkali?
A basic substance, i.e., pH 7.
What is a carbohydrate?
Organic compounds of carbon, hydrogen, and water. Typically with hydrogen and oxygen in a 2:1 ratio, respectively, these are often called sugars.
What is a ceramic?
An inorganic crystalline solid typically prepared by heating.
What is the chelation?
Binding of a ligand to a metal atom through two or more positions.
What is a crystal?
A solid with an ordered arrangement of atoms of molecules.
What is an aerosol?
Suspension of a solid or a liquid in a gas, e.g., smoke, fog.
What is a covalent bond?
The equal, or near equal, sharing of electrons between two or more atoms.
What is an acid?
A molecule that has easily removable hydrogen ions, Brønsted-Lowry acid. Can accept a pair of electrons, Lewis, or releases hydrogen ions in solution, Arrhenius.
What is the crystal field theory?
A model used to describe the electronic structure of transition metal molecules. Particularly the energy of the d orbitals.
What is a cathode?
Electrode where reduction occurs.
What is the activation energy?
Difference in energy between the reactants and transition state. Or activated complete, for a chemical reaction or process.
What is a catalyst?
Any substance that increases the rate of a chemical reaction without being consumed by the reaction.
What is the Coulomb's law?
Law describing the force between a pair of charged particles separated by a distance.
What is a cation?
A positively charged ion.
What is an alkali metal?
Group 1 of the periodic table, i.e., Li, Na, K, Rb, Cs, Fr.
What is a chemical bond?
Sharing of electrons between two or more atoms.
What is the critical point?
A set of conditions at which no boundary exists between two phases of a substance.
What is absolute zero?
Lowest theoretical temperature, 0.00 K, minus 273.15 degrees Celsius, minus 459.67 degrees Fahrenheit.
What is Celsius?
Common temperature scale in which the melting and boiling points of water are defined to be 0 degrees Celsius and 100 degrees Celsius, respectively.
What is the Charles's law?
A law stating that the volume and temperature of a gas are directly proportional.
What is an actactic polymer?
A polymer in which the chiral centers are arranged randomly along the chain.
What is a coulomb?
The standard unit of charge, defined as the amount of charge delivered by 1 amp in 1 second.
What is carbocation?
A cation in which a carbon atom bears a significant fraction of the positive charge.
What is a congener?
A polymer of 2 or more monomers.
What is a d orbital?
An atomic orbital with an angular momentum quantum number of 2.
What is a carbanion?
An anion in which a carbon atom bears a significant fraction of the negative charge.
What is an aliquot?
A sample taken from a larger amount of a material.
What is process accuracy?
Closeness of a measurement to the actual or accepted value.
What is the Curie point?
The temperature at or beyond which a ferromagnetic material becomes paramagnetic.
What is a chalcogen?
A group 16 element, oxygen, sulfur, selenium, tellurium, polonium, or livermorium.
What is crystallization?
Formation of crystals from a solution of the compound, often used as a purification technique.
What is Dalton's law?
A law regarding partial pressures of gases that states the total pressure of a mixture of gases is equal to the sum of the partial pressures of each individual component.
What is the condensation reaction?
A reaction in which two molecules combine to form one larger molecule, with the concurrent loss of another small molecule like water or HCl.
What is absorption?
Capture of one material into another, can be a physical or chemical.
What is an adiabatic?
A process that does not absorb or release energy.
What is a dative bond?
A chemical bond in which one atom is essentially providing both electrons involved in the bond.
What is a dative bond?
A chemical bond in which one atom is essentially providing both electrons involved in the bond.
What is a de Broglie wavelength?
Also known as matter wavelength. Inversely proportional to the momentum of the object or particle, see also wave-particle duality.
What is a de Broglie wavelength?
Also known as matter wavelength. Inversely proportional to the momentum of the object or particle, see also wave-particle duality.
What is a decant?
To pour off a liquid from a solid sediment.
What is a decant?
To pour off a liquid from a solid sediment.
What is the decay rate?
Rate at which a nucleus emits a particle.
What is the decay rate?
Rate at which a nucleus emits a particle.
What are degenerate orbitals?
Atomic or molecular orbitals of equal energy.
What are degenerate orbitals?
Atomic or molecular orbitals of equal energy.
What is density?
Mass per unit volume of a given substance.
What is density?
Mass per unit volume of a given substance.
What is a dependent variable?
A variable that changes as a function of the independent variable.
What is a dependent variable?
A variable that changes as a function of the independent variable.
What is dextrorotatory?
Having the property of rotating plane polarized light clockwise.
What is dextrorotatory?
Having the property of rotating plane polarized light clockwise.